Hi guys, welcome back to my channel Pirai Academy. In this series of Zoho interview question, today we are going to see about a question called rotate array by some degrees. So it is basically a important question and also most frequently asked question in Zoho. So there are three types of questions they may ask. So these are 90-degree clockwise or 270-degree counterclockwise rotation of an array, or else rotate array by 180-degree, or else 270-degree clockwise or 90-degree counterclockwise. So basically, what is meant by clockwise? So clockwise means like this direction, and anti-clockwise means like this direction. So it is called as anti-clockwise or counterclockwise, whatever. Okay, and if they have given a clockwise and we want to convert it into a counterclockwise, then we should be subtracting it from 360-degree. Okay, so 360 minus clockwise is equal to anti-clockwise. Fine. Okay, so from this I can tell you that the relationship between this 90-degree clockwise and 270-degree clockwise. Hope you understand this. Fine. But for this 180-degree, whether it is clockwise or counterclockwise, both are same. Fine. Now let us get into the logic behind this each and every topic. Fine. Now rotate array by 90-degree. So what it means? Initially my array or matrix is like this. So it will be basically a matrix. So here I have demonstrated with n into n matrix. Okay. So in this n into n matrix, I have given some matrix like this, and you have to just rotate that into a 90-degree. So if I rotate this into 90-degree, then it will be something looks like this. Can I understand this? So what is meant by rotating 90-degree? The array is like this, or matrix is like this. Then if I rotate this 90-degree, it will be like this. Can you understand this? Or else this from this is different part and this is different part. So I will be just rotating 90-degree. Hope you understand this. Fine. Okay. So what are all the observations you have found here, so that we can build a brute force approach? So basically I have clearly stated, I can clearly observe that this 7 has gone here and this 4 has gone here and this 1 has gone here, which means this entire column is converted into this entire row. Okay, now this entire entire column is also converted into entire row, and this entire column is also converted into this entire row, which means our row is converted into a column. So it is basically like I can construct another resultant matrix. Okay, and I will be traversing from down to the top in column wise, and I will be arranging it in the row, so that it will be like 7 4 1, and then now I will be traversing here and it will be 8 5 2, and I will be traversing here, it will be 9 6 3. Okay, but it takes a time complexity of what? O of n square, and space complexity of what? O of n square, because we are taking a auxiliary matrix. If the question is not about the n into n matrix, then this will be my optimized solution. But the question is what? N into n matrix. So we can further optimize it. How can we optimize it? So the optimization technique here will be, we are going to do in place. So how to do this question in place? Fine. So what are the observations I have made? So first observation is row is converted into, a column is converted into row. Yes, column is converted into row. Whenever a row is converted into column or column is converted into row, which tells the transpose. If you have already studied the matrix in your math, then it will be so easy what is meant by transpose means. Okay, if you don't know about transpose, just go and watch that and then just come back to this video. Okay, fine. Now what is our actual matrix? It is 1 2 3 4 5 6 and 7 8 9. Okay, now if I take a transpose of this matrix, okay, what will be my transpose? So let me rewrite it so that it will be more clear. Fine. Now if I take a transpose, then what will be my result? My result will be 1 4 7. This entire column will be my entire row. then this will be going to my column. So it will be 2, 3, then here comes 5, then here comes 8, here comes 6, here comes 9. So this is my transpose of the given matrix. Okay, now what else I have to do so that my actual result will be something looking like this. Okay, this is my result, right? This is my result. So what should I do to this matrix so that it will be looking like this? So if you clearly see that I want to reverse each and every row, I want to reverse this row and this row. If I reverse each and every row, I will be getting the result. So it can be done in place, right? So now tell me, what is the time complexity of the optimized solution? It will be O of n square, and space complexity will be O of 1 because it is in place. Hope you understand this approach. Fine. Now let us go to the next problem statement. So if they have given rotate the matrix by 180 degree, then how can we solve this? So just listen this carefully. If the given example is like this, then the given output will be like this. Okay, it is like, initially it will be like this, then 90, then again 90, which means 180 degree rotation. Okay, so I can either tell this as, we can do this by using the 90 degree code plus again 90 degree code, which is equal to 180 degree. We already know the 90 degree logic. Okay, so I want to apply this twice so that I can achieve 180 degree. Simple, right? But whether it is efficient? No. We can directly make this matrix into like this. Can you understand this? We can also use auxiliary space for brute force approach, but the brute force approach by using the auxiliary matrix, which will be easy, but its time complexity going to be n square and space complexity will be going to the n square. Okay, so it is not an optimized solution. So to optimize this, we want to do in place. Okay, what is my observation that is held here? We want to observe where my entire row or each and every element is gone through. Okay, this entire row has gone to the last. Okay, so here it is not gone to the last, but it is reversed also. Here also it is reversed. So this 7, 8, 9 gone to the first row and it is reversed. So it is basically, I am just taking each and every row and reversing each and every row element, also reversing each row. Hope you understand this. Got it? So first of all, I will be making this as what? Like 7, 8, 9, 4, 5, 6, 1, 2, 3. Then again, I am doing what? Each row element will be swapped or will be reversed in place operation. Okay, so it will be something look like 9, 8, 7, 6, 5, 4, 3, 2, 1. Can you understand this? So what is the operation held here? Held here is, we want to reverse rows. Here reverse each row. Can you understand this? So these are the two operations that can be done in place to obtain the 180 degree rotation of the matrix. So what is the time complexity? It will be O of n square. And what is the space complexity? It will be O of 1 because it is in place. So in that problem solving round, okay, or in assisted HR round, okay, in that they will be asking you to optimize the solution again and again. In that time you will be ending up in the optimized solution called this in place. Okay, fine. Now let us go to the last question. So it is rotate by 270 degree clockwise. Also they can ask like 270 degree 90 degree counterclockwise. Okay, so here if they given matrix like this, then it will be converted something like this. Like if this is the matrix, then 270 degree clockwise means 90, 180, then 270. Okay, it is in clockwise, but in counterclockwise it will be 90 degrees. So here to here. Can you understand this? Fine. Now how to do this? So for this also we can do 90 degrees code plus again 90 degrees code plus again 90 degrees code, which is equal to 270 degree. Or else you can do like 90 degree code plus 180 degree code, which is equal to 270 degree. So you can do either method, but it is indirect method. But we want to do a direct conversion from the matrix to the 270 degree clockwise rotation. Can you understand this? So it will be more and more useful when you are countering a efficient solution. Fine. So here also you can use a auxiliary matrix. Okay. But it is a brute force solution of time complexity of O of n square and space complexity of O of n square. Okay. So that we are going into an optimized solution for the in-place approach. Okay. First of all, we want to use some observation, right? Okay. Make an observation. So 1, 2, 3, this 1, 2, 3, this entire row is converted like a column here. Okay, and this entire row, the second row is converted into a column here, and this entire row is converted into a third column. So from this, I can tell you that a row is converted into a column, which means we are going to take a transpose. We are taking a transpose because whenever we are encountering in a matrix problem like a row is converted into a column or column is converted into a row, we are going to a transpose. So first of all, we are going to take a transpose. So if I take a transpose, it will be something looks like 1, 4, 7. Here comes 2, 5, 8. Here comes 3, 6, 9. Fine. Now, what should I do to convert this matrix into my resultant matrix? So it is basically like I want to just reverse each row, not each row elements. So I want to reverse each row alone so that I can obtain this. So it is also in place operation, right? It is also in place operation. So I can tell you that we are doing this in time complexity of O of n square and doing this in a space complexity of O of 1. Yes. So this is the optimized solution we can obtain to do in a 270 degree clockwise direction or 90 degree counterclockwise direction. Hope you understand this. Now there will be a quite recap for each and every problem statements. Okay. For rotate by 90 degree clockwise, what we are going to do? We are just taking a transpose first. Plus, next, what step we have encountered? We are just this is the transpose, right? Now, next, what we are doing? We are just making each and every row elements in reverse order. So, reverse each row elements. Fine. Now, if it is for 180 degree, then what we are doing? We are just reverse each row plus reverse each row elements. Fine. Now, if it is for 270 degree clockwise, then take a transpose and then we want to reverse each rows. That's it. Because that's what I have said here also, right? Okay. So these are the main logic behind this all optimized approach for the rotation problem. Okay, now it's time to see the code. Always prefer a Java code. So see here, first of all, rotate by 90 degree clockwise. So here, first of all, we are just taking the length of the matrix and then I want to just take the transpose of the matrix in place, right? To do that, I'm just making sure to traverse from 0 to n up to n. Then again inside that inner loop will be traversing from that I to n because we don't take the previous elements. Okay, we are going to start with the current point to the last point. Okay, so that's what we are going to do here. But if you're going to use a 0 here by mistake, you have done a mistake like putting a 0 here, then it will be leading to the original matrix. Okay, it will be like in transpose, we will be making our row into column. Okay, when I am using 0 there, it will be again doing row to column. It will be convert again the row to the column, which means it is again coming to the original part of the array. Sorry, matrix. Okay, so be careful while you are writing the transpose code. I will be giving you the link in description for this transpose code. Okay, now reverse each row. It will be quite easy for you, right? We are just traversing, and we will be traversing in each and every row, and we will be just swapping the each and every row elements. That's it, right? So it will be quite easy. Fine. Now let me submit it. Yes, it is submitted successfully. Now let us go to the next problem code. It is 180-degree rotation. So here I will be taking the matrix length and storing in n, because it is n into n matrix, right? So similarly, now first of all I am going to just reverse the each and every row elements. Fine. So I will be traversing in the entire row, and I will be making my row elements to be swapped. Like the first element will be swapped with the last row element, and second row element will be swapped with the second last row element, like that. Okay. So after doing this, all the row elements are reversed. Now I want to reverse the rows. So to reverse the rows, I will be traversing up to the half of the row. Okay, and I will be just swapping the first row with the last row, second row with the last second row, like that. Fine. Now let me submit it. Yes, it is submitted successfully. So here we are using a temp, right? Temp of size n. So that's why we are just getting space complexity of n. Okay, I forgot to tell that. Here you will be getting space complexity of O of n, and here you will be getting a space complexity of O of n. Okay, because we are using a temporary variable to store the entire row. But in Python it will be quite simple. You can swap the entire row with another entire row. Okay, but in Java it will be somewhat space complexity will be there. Fine. Now let us go to the rotate of 270-degree clockwise rotation. So first of all I am doing a transpose of the matrix. So already I explained this in the 90-degree rotation itself. Now I want to just what should I do? I should be just reversing the each row, not each row elements, right? So I will be here also storing the each row in my temp, and I will be reversing it. Okay, so it is like I will be taking the first row and the last row swap, second row and the second last row swap, like this. So let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. Don't skip any videos in this Zoho playlist, because all the videos will be important when you are appearing for your interview. Thank you.